Next, I'd like to introduce Joseph Khoury. Joseph is a computer engineer who enjoys solving hard problems. He has experience with many languages, but he enjoys JavaScript the most. Outside of work, he enjoys building robots, rock climbing, playing music, and of course, spending time with his family. Joseph, come up on stage and floor is yours.
So yeah, hi everyone. I'm going to be talking about memory leaks in JavaScript. As we know, JavaScript is a language that we don't worry much about managing memory, which means assigning like space somewhere in the physical memory for variables. It's a garbage collected language, so we just use variables and we leave a function and the system would take care of these. But the garbage collector is not perfect, and the way we write our code sometimes, even with the best algorithm in the garbage collector, we still gonna get these memory leaks. So I'm gonna jump directly into explaining what memory leaks are and how they happen. So on the right, you see here a graph, and this is a memory of a system, or let's say the heap. It's called the heap in JavaScript. And the blue area is what we're using out of that memory. So when we run some code, some pattern, we create like some DOM elements, let's say if we're in the browser, or we serve a request in a Node.js server, we consume memory while we're using these variables. But then when we don't need them anymore, the garbage collector would jump in and would clean these memories. So it kind of clean the memory of these variables. And that memory is the heap. And the orange part is the amount left for us to use. That's the maximum default heap. For example, Node.js is 2 gigabytes, but it's a variable. It's something that we can change. In Chrome, I believe it's still 2 or 3 gigabytes. So what we need to learn about how the garbage collector works briefly is that it, like, every time we create a variable, an object or something, that this object is created somewhere in a function, or it's a part of another object. So it creates a tree, and it's a tree connecting one to the other, so it's called reference. So every time the garbage collector runs, it tries to find which objects do not have references anymore, like that they're not needed anymore, and it cleans these. Sometimes things are left behind. What we also need to know is that whenever this garbage collector is running, it stops the program. Like the program can't do anything until it's done. In a normal case, it's not a problem. We don't feel it. It's really quick. We also need to know that the garbage collector, whenever it runs, the amount of time that's taken is proportional to the number of objects and variables and arrays and like all the stuff that we're using. So if you check here the red areas, these are the time required, not vertically, I'm talking like horizontally. So horizontally, it's the amount of time that's being taken for the garbage collector. And these are the times where our server is not responsive, our UI interface is not responsive in a browser. So we really need to keep this time as small as possible. Now, this is, for example, a program where it's been running normally. Memory is going a little bit up and down on the left side. But then we just push something like a new feature, something like we're trying to fix some bug, but unintentionally we introduce a memory leak. So a memory leak, again, is the memory that's supposed to be freed, but is not. In this case, if you look at the ups and downs here, like the up and down on the middle, this is where we're using the system, and it's using variables. The garbage collector is freeing most of them, but not all of them. Most of them, not all of them. Over time, there's an accumulation of lost memory space. And that lost memory space is considered a used memory space until we hit that max heap. And then something would happen, like everything becomes unresponsive, the server would crash, the page would crash, or we just restart it manually or refresh a page. So why should we care? In a normal page where it's just one single page, you visit, you fill a form, you read something, you click out, you move out, it's not a big deal. Even if there's a memory leak, it's not a big deal. But in a single page app, where the app is open for weeks and weeks, for example, Slack for the web, WhatsApp, like all this stuff, Gmail, I never close these tabs. So they're open all the time. This is like even a tiny memory leak would accumulate over time, and it would make the system really unresponsive. So there's a response time for users. There's a memory cost on the servers. If you're on a mobile phone, this would drain the phone battery. Every time the garbage collector would run for milliseconds and then seconds. Of course, higher CPU usage. It's really like your laptop fan is running all the time. So these are like, I would call them 5 or 6 coding patterns that leak JavaScript, but like 2 are added that been kind of really recently fixed. I'm gonna jump into these directly, which is the event listener. Usually if you have an event listener attached to a DOM and then you remove that DOM, it used to be that that would leak, but recent change, the garbage collector has been kind of smarter in detecting these and not leaking most of the time. Another one is the console log. I'm going to talk about this more. So a global variable, for example, inside function, we forget to use var something, or let, or const, or and that would automatically create a global variable, which is in a browser, it's like window.myvar, something like that. So usually if it's inside a function, the function returns everything inside that function. If it's not referenced somewhere else, all these variables would be deleted. But in this case, it's not going to be deleted if it's a global var. Caching, if we're caching anything, and we keep adding to the cache and we don't have a mechanism to remove old stuff, then the memory is going to be filled. While this is not a problem of the garbage collector, it's a problem the way we're using the memory. Collections, which is like objects, arrays, all these stuffs, maps, same thing. If we add stuff to them and we reference them some way, they will stay in the memory. Timers, set interval, set them out, mainly set interval. If we attach it to something and that something disappears, or we need it once and still running in the background, that will leak memory. Closures, same thing. I'm not going to get into much details. The rest, actually, there's one more, so I'm going to do it, which is the whenever we're loading a lot of DOM nodes, for example, you're going into Facebook or Instagram and you're scrolling. Every time you scroll, you're just loading more stuff. If you don't remove the previous stuff from the DOM and from the memory, then your memory is growing until basically the page crashes. There are many tools to find memory leaks. I'm going to be talking about one mainly. I added the second because I just had a look at it and it's really nice tool. It could be used for testing as well. You can write tests using this tool. It was open sourced by Facebook recently, probably last week, two weeks ago. But I'm going to demo how to find memory leaks using the Chrome developer tools. So let's jump into. So to open the developer tools, there are 2 ways, 3 ways probably. You can go into developer tools here, or usually I just right click, go to inspect, and then I get everything that I need here. So I'm going to show some of the source here. In this example, We have a function. This function is supposed to leak memory. Assuming this function basically would get some array from somewhere. In this case, I'm just using static array. And then we get these numbers, and then we return that array. But I want to be able to run this like a 10,000 time, 100,000 time. So there's another function here. You don't need to look at much of the code. I'm just going a loop 1,000 times every time I click this one here. So it calls this function, gets the array, use the numbers from the array, and add them into just a variable, a sum. And we're going to run this multiple times. So how to find memory leaks? There's a tab here, it's called memory. You can use the allocation to see like a graph of it, or you can directly use a heap. Usually the best way to do is to, whenever you have a fresh run, you just refresh, select the heap, and then take a snapshot. Now, this snapshot would take like an image of all the heap, all the objects, everything. And then we can use another image to compare. Now I'm gonna be running this start leak 10, 20 times, so multiple clicks. And then while this is running, I can take another heap snapshot. So like directly, if you look here, I don't know, maybe I should increase the, can you guys see the 4.7 megabyte? So the first snapshot, we had 2.8 megabytes. After using this page and we interacted with it, we see that the memory is growing. And if I use it some more, because sometimes the garbage collector does not kick in directly. So you might get like a false numbers if you just do it directly. So take multiple. So now I took another one, and you see the number is 6.8 megabytes. So it's consistently increasing every time I use the application. To find the memory leak, you go to the latest one, and then instead of summary, you compare it with the previous one. I'm going to compare it with the first snapshot. Now directly, just by doing this, if I go to this and I sort by the deltas, I see that we created like 260,000 new arrays, which is like near this number here. And then we only deleted 31. And the delta basically is what we can look at. And then we know that, okay, there's a problem in our arrays somewhere, and we need to find this, which array, which function, all these stuff, and then we need to fix it. Now there's a different way of doing this, which is, let me delete these, and then if we go to this one, and then just refresh, start recording, and then start doing this again a couple more times. How much time I still have? I think out of time. Okay. So in this one, we can have allocations. Where is that? Windows, fetch. So let's see. Allocations, objects. I think that's, my screen is too big. I can't see the rest of the stuff. Let me, in the meanwhile, because I still have a couple seconds, I'm gonna show you something back here. So in this case, we have a console log. As I mentioned before, console log leaks memory, but not while the dev tool is open. It used to be, but it was fixed probably a year ago or something. And right now it only leaks while this is open. So to fix it, there's two ways: either remove the console log or do not send objects, just send a string, array.join or JSON something. So I'm gonna just change one little thing in the code, refresh. So by doing this, go join, see. So I changed this to console.log array.join. So I'm not sending the whole object. I'm sending still a string. It is still a string being sent, but it doesn't leak the array itself. So let's just do a simple test here. Remove everything. Actually, not this one. Sorry. Memory, heap snapshot, and take snapshot 2.6, 1, 2, 3, 4, 5, 6, 7. And then we see 60,000, another heap size. It's still the same. Do use the page more and more and more. Take another heap size. And it's supposed to be the same. So now we kind of fixed the memory leak by just changing that console log from sending an object array to the console to just sending a string value of it, like a JSON stringify or this. I think I'm out of time. Back to this. These are references. I'm going to be sharing this with you guys. And thank you.